Okay, so let's talk about something a little bit ridiculous. Have you ever heard the question, can you cook a chicken just by slapping it? It sounds like a total joke, right? Well, today, we're actually going to take it seriously. We're diving deep into the physics behind this absolutely wild idea.
So there it is, the question of the hour. And yeah, it's kind of funny, but believe it or not, hidden inside this completely absurd premise is some genuinely fascinating science just waiting to be unpacked.
So for the next few minutes, we're going to treat this as a real physics problem. We're going to give it the scientific seriousness it probably doesn't deserve. But you know what? That's exactly what makes it so much fun. I mean, the basic idea just kind of makes sense, right? You rub your hands together really fast, they get warm. Think about a meteor hitting the atmosphere. It burns up from friction and compression. We know that motion and energy can create heat. The real question is, can you scale that idea all the way up to a full-on chicken dinner?
This is the perfect way to think about it. It's exactly that kind of thought experiment. We're taking a simple, real-world fact, and we're pushing it to its absolute, most illogical extreme, just to see what kind of science shakes out.
So, let's get into the nitty-gritty of how this would even work. To understand how a slap could possibly cook a chicken, we first have to talk about the energy of motion itself.
And the absolute star of our show here is kinetic energy. It's the energy that any moving object has. A rolling ball has little. A speeding car has a lot. And in our case, a hand moving at an unbelievable speed towards a very, very unfortunate chicken has an immense amount.
So the process, at least in theory, is pretty straightforward. Step 1, your hand is moving, so it's packed with kinetic energy. Step 2, you make impact. That energy has to go somewhere, right? It gets transferred into the chicken. And step 3, that energy gets converted into thermal energy, or, heat. The more kinetic energy you start with, the more heat you get at the end. Simple enough. All right, so let's get to the fun part. If we want to do this in one single glorious, all-powerful slap, what kind of speed are we really talking about? We're about to jump from theory to some very real numbers. And trust me, you're going to want to brace yourself for this.
The math has been done on this, and the results are just mind-blowing. To generate enough heat in a single blow, your hand would need to be traveling at hypersonic speeds. We're talking multiple times the speed of sound, faster than a fighter jet. This isn't really a slap anymore, it's a meteoric impact. And this is where our delicious culinary dream runs headfirst into a very harsh, very, very explosive reality. Because it turns out, when you apply that much energy that quickly, it doesn't work the way we want it to. It doesn't cook. Oh no. It does something far, far more dramatic.
And here we have it. On the left, our beautiful dream, a perfectly roasted golden brown chicken. And on the right, the catastrophic reality, an expanding cloud of plasma. The energy transfer is so powerful and so instantaneous that it doesn't have time to gently heat the atoms. It literally rips the electrons right off of them, tearing the matter apart.
So let's be absolutely clear, you do not get a meal. You get a small, chicken-flavored explosion. The very thing that was supposed to cook the chicken, that immense kinetic energy, ends up completely vaporizing it instead.
Okay, fine. One hypersonic slap is obviously a disaster. But what if we're clever about it? What if, instead of one giant slap, we try thousands of weaker but still really fast slaps? A more controlled approach. Surely that would work, right?
Well, no. The outcome is just as disastrous, just in a slightly different way. The sheer repetitive force would just pulverize the chicken into mush. It would shatter the cutting board it's sitting on, and of course, it would completely destroy your hand in the process. We're talking total system failure here. Which brings us to our final, inescapable conclusion. No matter how you slice it or slap it, you cannot cook a chicken this way. The big lesson here is that the rate at which you apply energy matters just as much as the amount. Too much energy applied too fast, and you get an explosion, not a roast dinner. So, while our poultry experiment was a spectacular failure from a cooking perspective, it proves that physics is hiding in the most ridiculous places. It shows that even the silliest what-if questions can lead to some really serious science. And that really makes you wonder, what other kitchen myths are out there just waiting for a scientific takedown?